Welcome to qnawire.
Here, we've defined the force needed for one acrobat, symbolized here by the red dot, to hold up his partner, black dot with a blue circle around it, and swing them in a circle. So I've drawn a free body diagram for the acrobat, which is represented by the black dot down here. So we have our force of tension, which is pointing upward as the other person holds them, and our force of gravity, which is pointing down. Now, our force of tension is split into two components. The y component, which balances out the gravitational force, and our x component, Tx, which is responsible for the centripetal force. We can say that Ty equals Fg, and Tx is mv squared for r. And T is, of course, equal to Ty plus Tx, since we're just adding the components together. So the force of tension is the amount of force that the first acrobat, the red dot, must apply in order to hold their partner up. So the total force needed must be equal to mg, for gravitational force, plus mv squared over r. Now, all we have left to do is to plug in. So we know the weight of a person equal to mg, that's 475 newtons, plus, now plugging in for our centripetal force, that's 4 meters per second squared, our velocity, over 6.5 meters, that is our radius, and that is all multiplied by m, which is going to be equal to 475, cutting me off there, is going to be equal to 475 divided by 9.8. And that is just because weight equals mg, so since we're just multiplying by m, that's going to be weight over g. And this is going to be newtons, and this is meters per second squared. Now, when we solve this equation, plug all of it into our calculator, we find that the tension must be equal to 594.309 newtons. And that is our final answer.